Corrugated material is manufactured and utilized in an environmentally friendly process that ensures the preservation of our natural resources. The process starts from the responsible management of raw materials, followed by the manufacturing of paper and corrugated material. The corrugated fiber is then recycled and used to create new corrugated material in a never-ending cycle. This module will explore the raw materials used to make paper and the combined board that is used to create boxes. By the end of this module, you will be able to Corrugated packaging is renewable. The journey of the corrugated box begins in a sustainably managed forest. There, certified foresters and loggers harvest just enough trees to make packages. And for each tree harvested, 3 more are planted to take its place. Corrugated cardboard is made from a renewable resource that is harvested as a crop. The trees that we use for this purpose have a longer growing cycle, and once they are harvested, we plant them again to produce more fiber. This allows us to use the same land repeatedly and sustainably. Whether the boxes you use are brown or white, made from newly harvested fiber, 100% recycled fiber, or something in between, the fibers that make up the box were once in a growing plant. In the papermaking process, the fibers are separated, but still retain their cellulosic structure and other attributes of the original plant. The fiber source and recycling process used can have an impact on the properties of the material produced. In North America, containerboard fiber comes almost exclusively from forests. Here, trees for paper and wood products are grown mainly by private landowners on family tree farms using reforestation practices. Paper products made primarily from different types of trees, including softwood and hardwood, are said to be primary or virgin. Complete the interactive lesson titled Fibers for Packaging to learn more about the types of trees used to make different components of corrugated packaging. Another major source of fiber is recycled paper, paperboard, and containers, old corrugated containers, or OCC. This is both pre-consumer, that is, waste clippings and trim from the manufacturing process, and post-consumer, where used materials such as corrugated boxes are collected from the consumer and reprocessed. Around 90% of corrugated packaging produced in the United States is reclaimed and recycled, more than any other packaging material in the world. Both fiber and liner can range from 100% virgin wood fiber to 100% recycled fiber. Likewise, medium, the fluted paper in the middle of the corrugated, also called combined board, typically contains anywhere from 80% virgin wood fiber to 100% recycled fiber. The OCC fibers are typically pulped using water and agitation to separate the fibers, so again, they can be made into containerboard sheets. The proportion of recycled material in corrugated fiberboard end products has been steadily increasing. The average box contains 52% recycled content. Fibers obtained from recycling are called secondary fiber sources. Corrugated manufacturing processes ensure a balance between harvested trees and recycled fibers, working toward efficiencies that strengthen a circular approach to sustaining forests. Without virgin fibers being added to the manufacturing mix, the US would run out of corrugated boxes in 6 months because fibers deteriorate or become shorter during the recycling process. This is why a steady supply of fiber from both sources is needed to support continuous box production. Corrugated is made with just 3 renewable natural ingredients: wood fiber from trees and OCC, water, and starch. Cellulose fibers in wood are bound together with natural glue called lignin that need to be separated for papermaking. The separation process is known as pulping. Paper mills use pulping methods to separate the fiber and ultimately create containerboard. The goal is to maintain the fiber's length and chemical nature, as those contribute to valuable sheet properties. After pulping, the refined and cleaned fibers go through what is called the fourdrinier process to form large rolls of linerboard, which is used as the outer facings of containerboard at the end of the paper machine. Complete the interactive lesson titled The Fourdrinier Process to learn more about the process of turning fibers into rolls and ultimately corrugated fiberboard. Containerboard is a general term for the 2 basic types of paper used in making combined board: liner and medium. Each has a different purpose and thus has a different content and construction. Liner is used as the outer facings, and medium gets fluted and attached to the liner. Liner is typically produced on a four-denier paper machine and is available in several basis weights, colors, and with special surface treatments to suit customer needs. It can also be pre-printed with customer graphics. Two types of liner are produced in North America: basis weight grades and performance grades. Since it has a different function, medium isn't made from the same material as liner. Large rolls of medium are loaded onto the corrugator, where the material is preconditioned with heat and steam to make it pliable, so it can be formed into flutes. The flutes are formed by running the medium through corrugating rollers that have intermeshing ribs. The load capacity of corrugated boxes depends on the compression strengths of each of the papers and how they are combined. Liner and medium can be combined for a variety of structures. Corrugated packaging combines structural rigidity and cushioning qualities to protect both fragile and heavy contents from damage. Complete the interactive lesson titled Types of Combined Board with details about the different board combinations such as single face, single wall, double wall, and triple wall to learn more. Corrugated board is not manufactured in just one form. Liner types and thicknesses can vary. Medium fiber content and thickness can vary. Flute heights can be different. The board can be a single face, single wall, double wall, or triple wall. In fact, hundreds of different configurations exist, each with its own advantages and uses. Because of all the different forms and configurations, the corrugated industry has established standardized specifications which allow communication of what is needed and what should be produced. This allows a product designer to communicate exactly what's needed in a complex shipping container, or allows a customer to establish what his needs are for a point-of-purchase marketing display. Complete the interactive lesson titled Specification of Corrugated Products to learn more about basis weight, colors and finishes, and standard industry flute heights. Test your knowledge of standard flute heights and complete the interactive lesson titled Corrugated Board Grade Identification. The thoughtful specification of linerboard and medium grades can produce end products with specific, customized performance characteristics that can meet or exceed customer demands and expectations. Over 1,100 box plants throughout North America produce corrugated packaging. There are two different categories of corrugated manufacturing companies. Integrated corrugated manufacturers, as the name says, are vertically integrated and do everything from forestry to finished boxes. Integrated companies are generally publicly owned, and the containerboard they produce may go to their corrugated plants or be sold on the open market. Independent corrugated manufacturers are smaller and tend to be privately or family-owned businesses. They purchase raw materials to make finished products. According to the Fiberbox Association, an independent buys more than 50% of the raw materials from other companies to produce their own finished products. Within those company categories are three different types of plants. A corrugator plant manufactures combined board sheets, but also processes the combined board into boxes or other finished products. A sheet plant purchases the combined board sheets from a sheet feeder or corrugated plant, and then converts them into a finished product. A sheet feeder manufactures containerboard exclusively to supply sheets to box plants. One sheet feeder plant may supply combined board for several sheet plants. The basic operation of a box plant is to combine rolls of paper to produce combined board in a continuous web that is then formed into various types of boxes. To accomplish this, three basic new materials are needed: paper, steam, and adhesive. The paper weights available to box plants range from less than 17 pounds per 1,000 square feet to more than 96 pounds per 1,000 square feet. Box plants order containerboard, which matches the needs of most of their customers, in roll widths to fit the sizes of their machines. Box plants can also have capabilities to apply coatings and other processes that alter and improve the box's attributes. Steam is the driving force needed for everything, from making the adhesive to conditioning the layers of paper and heating the pressure vessels that help bond the liners to the fluted medium. Steam generation is a complex process that is not generally well understood by those who don't work with it directly. The liner and medium that make corrugated board are combined using a starch adhesive. This adhesive is typically composed of food-grade cornstarch, water, and additives that control the adhesive's moisture resistance and fluid properties. It is applied to the surface of the flute tips of the medium. and the flute tips are brought into contact with the surface of the liner. Temperature control is critical for this process to occur correctly. The typical starch adhesive has very limited moisture resistance. Resins are added to the adhesive formulation as needed to provide a level of water resistance. The three basic raw materials needed to produce combined corrugated board, as discussed above, paper, steam, and adhesive, are put together on a corrugator. Corrugators integrate a series of operations through which the liner and medium are combined to form the rigid end product, sheets. Complete the interactive lesson titled The Corrugator to learn more about the corrugating process on the plant floor. Other attributes can be built into the combined board during the corrugating operation. The corrugator can also be set up to produce double wall and triple wall with additional single-face resections. A corrugator is a large, highly automated machine and can be operated with a relatively small crew of 4 to 5 workers. These high-speed machines are capable of producing 9-foot wide by 800-foot long sections of corrugated board every minute. That could wrap around the Earth's equator approximately 16 times in just one day. That's enough corrugated board to embark on a corrugated journey across the globe and still have plenty left for packaging adventures. Corrugators must be flexible, and changeovers can happen several times a day, depending on demand. A typical changeover may include liner caliper or thickness, medium thickness, flute size, scoring dimensions, widths, and lengths. Different types of equipment turn combined board sheets produced by the corrugator into box blanks and then boxes. A box blank is a flat sheet of combined board that has been cut, slotted, and scored. Die cutters use cutting dies to put slots, scores, holes, or notches in the corrugated sheet where needed. There are two main types of die cutters, those that use rotary dies and those that use flatbed or platen dies. The result is a fully cut, slotted, and scored container in the flat called the blank. While some boxes require the use of a die cutter, others can use equipment called a folder gluer. With this one-stop shop, corrugated sheets are loaded onto the equipment where it scores slots, folds up, and glues the seam called a manufacturer's joint. This process converts the sheets into flat containers that only need to be opened and have their flaps folded and fastened to make the boxes. These ready-to-be-formed boxes are called knockdown boxes, or KD. One of the advantages of corrugated packaging is its ability to accept printing directly on its surface. Often, the printing operation is accomplished in conjunction with the folding and gluing operation on a flexo folder gluer. Flat corrugated sheets go in. Printed, knocked-down boxes come out. Depending on the job, the printing operation may be performed on a specialized printer. In today's retail market, packaging serves a much broader function than just storing the products. High-quality graphics in multiple colors can be generated either in conjunction with other procedures or on a printer that operates independently. The package often needs to assist with the sale of the product and provide information to customers. Graphic designers are responsible for making the box serve as an effective sales tool. To create the packaging design, designers use CAD or CAM software. Thank you for tuning in to watch Module 3, A Box's Journey from Papermaking to Converting. After this module, you have now learned about the papermaking process, corrugated fiberboard, specifications of corrugated board, types of plants, making containerboard, and converting corrugated fiberboard to boxes. Two resources with additional information on the subjects covered are the Fiberbox Association's Fiberbox Handbook and the Institute of Packaging Professionals' Fundamentals of Packaging Technology. We encourage you to spend time on the other corrugated industry curricula modules and additional files within this curriculum, and on our website at www.careersincorrugated.com to learn more about the corrugated packaging industry. The International Corrugated Packaging Foundation's programs and services are designed to help students, graduates, and job seekers find rewarding, lifelong careers in corrugated.